Okay, so now we're back. Distance of one, we call it a wave cycle, which equals crest to crest or trough to trough. Okay, this is called. Does anybody have a name for this? This little box I put on here, or it could just be a line. I just want to make it so you could see it. This is just called a marker. And it's used to find frequency of waves. Or how many per second. So I just count how many pass there every second. It's just called a marker. All right, so we're going to take all this wave information, and we're going to remember it, because you already know most of it. We're going to use it to do some math, different qualities from waves. And we're going to work with three things when we do this. And it all has to do with the color of light. We're going to work with wavelength, frequency, and speed of light. The wavelength has a variable. You know what it is. We already wrote it down on the other diagram. The variable for wavelength looks like this. Kind of like an upside down Y. And that is a Greek letter, and it's called lambda. My units for wavelength are meters. For frequency, my variable looks kind of like a cursive V. It's like that. And that is the Greek letter nu, N-U. And it is measured in something called hertz, the measurement for energy, which is Hz, and it means cycles and waves per second. Now, let me ask you some questions about the speed of light. Do you know what the speed of light is? Anybody know the real number? You do? What is it? Can you put that in scientific notation for us? Oh, come on, you can. 300 million. A million is 6 plus 2 is 8. You're right. It is. It is 3 times 10 to the 8 meters per second. What's the variable for it, Connor? Do you know that? You know that? No. Okay, so the variable for it is c. It's not a Greek letter. It's c for constant. The speed of light never changes. It's a constant. If I were to write it in centimeters, it would be 3.0 times 10 to the 10 centimeters. You just move it like you do when we're doing other conversions. So this is a constant value. Anybody know what? Oh, we already did that. Anybody know what formula it's used in a lot? Maybe the only place you've ever really seen it? E equals mc squared. The energy is equal to the mass of the body times the speed of light squared. Anyhow, that's just extra out there stuff. we put all of this stuff together, and when we're talking about light, we can say that the speed of light is equal to the wavelength times the frequency. Speed of light is equal to the wavelength times the frequency. I would think that you would want to pull your card out, and let's put C equals, put that on there, and then let's put this on here. Then I'm going to stop. We'll do one problem tomorrow, so you've got an example in your notes, and then we'll move into lab. So put both of those on your card, so you've got them for later. We get out at 42, right? Okay, that won't work. Hope you're having fun, Evan, while we're at school.